The elements, a visual explanation of every known atom in the universe. All of these nice guys here. Today we're looking at elements number 6 all the way to number 10. Here we go! Let's start off with carbon. Carbon itself is known as the molecule of life, the atom of life, whatever it's called. It is the most important atom in life, period. Nothing else is more important. Sure, there are many other species out in the world where life will probably be based on something else, but we as a species are carbon-based life. From the backbone spiral of DNA all the way to everything else. Carbon is the element that holds us all together. It also creates one of the most valuable substances in the entire world. Diamonds. Diamonds naturally created are very, very expensive and very, very beautiful as well too. In fact, you can sell them for lots and lots of high prices. But the ones that we create nowadays in the manufacturing places, they use carbon too, just in a less direct form. It's less hard, it's not as sharp, but it looks the same, feels the same, and it's just as about tough. Another well-known fact, the organic compounds term is used to talk about molecules that are based on carbon. Solely based on carbon or part of a carbon chain. That's what organic chemistry is about, just the studying about carbon. And what you think is called lead inside the pencil? Well, let me show you. Please focus on this. Yes. This pencil lead, which for some reason is not in focus because there's a person in the background, is actually made of carbon. Every time you write something, it's just a layer of carbon coming out. It's not actual lead, otherwise you'd die of poisoning. And now we use it to date things. We can use it for carbon radio dating. And because of that carbon radio dating, we can use it to go ahead and date stuff. Next up, we have nitrogen. Except first, here's our atomic weight for carbon, density 2.26, atomic radius 67 picometers, and crystal structures that. There's a lot of forms of it, but mostly it's solid, and then it's still low on the electron filing order. The atomic emission spectrum itself is kind of low too. It's mostly solid, and there's some of it it's liquid, but some of it is also air. Alright, next up we have nitrogen. Nitrogen is the 7th element on our list, and at the same time that our modern civilization has been pumping CO2 into the air, there's also another greenhouse gas that we should have been worried about. Nitrogen, or should we say N2. Nitrogen is N2 in the air. We can just use it as a greenhouse gas. Basically, it's cow farts. You heard me right, yeah, it's cow farts. It's like where ammonia comes from. Nitrogen itself as a liquid, it's kind of toxic, do not drink it. And in other ways, it's kind of great too. In fact, we use it mostly in the air. Nitrogen itself is really important to the soil, and we have to use it too. Nitroglycerin itself is used as a little flammable material. Sometimes though, a little compound known as silicon nitride, as silicon 3 atoms, nitrogen 4 atoms, it's very hard. In fact, it's so hard that we use it in cutting tools as well too. Silicon nitride ceramic balls are really good because they're very slippery as well too, which is why we put them inside wheels. Wheels that are slippery will roll faster. And rolling faster equals less friction, and less friction equals speed. Gotta go fast, gotta go fast, gotta go fast. Its atomic weight is 14.0067. The density is 0.001251. The atomic radius is 56 picometers. Its crystal structure, again, it's a hexagonal thing. It's the atomic emission spectrum is starting to come up, but also the electron filing order, it's also kind of a little low as well too, and it only is in gas form. Yeah, sure, we can go ahead and make liquid, but in nature we only find it as a gas. And now we have oxygen. If carbon is the molecule, is the atom of life, well, oxygen is the fuel of life, in the sense that we use it to run our machines. Now, we humans are not made mostly of oxygen. In fact, we're made mostly of nitrogen. There's more nitrogen in our body than oxygen, but we have to use oxygen because it's the only way we breathe. If we breathe nitrogen, that would be a different story, but since we breathe oxygen, we put all that air into our body, we use it to pump up, and we use it to charge up. Carbon dioxide is pumped out of the body. What I'm surprised about is why hadn't our body evolved to turn the carbon dioxide into O2, which we can use? Maybe someday we'll figure out why we can't take out the carbon. But for now, we just breathe oxygen, and we use it to go ahead and take it out. When your plane is crashing, the first thing you need is oxygen. When someone is dying of fainting, well, firstly, you need oxygen. And when someone's having, like, mountain dizziness or mountain sickness or car sickness, you need to give them oxygen, which I had to do once, even though it tastes really bad. Oxygen can be represented like this. Just get a clear bottle and cap it. There, you got some oxygen locked in there. Oxygen is just air. We have an atomic weight of 15.9999994, which is about 16, so about double the atomic number. We have a density of 0.001429. We have an atomic radius of 48 picometers. And then we have the crystal structure that's a slightly oblong rectangular cuboid. Alright, so the electromagnetics, like the atomic emission spectrum, is starting to go up. It's only found in gas form in nature, and its electron filing order, finally we crossed the 2p line. Next up, we have fluorine. What do you think we put in our toothpaste? Well, we put in fluorine. Now, fluorine itself, it's really useful inside cleaning your teeth. And it's really hard to contain permanently. Fluorine is among the most reactive of all the elements. If you blow a little stream of fluorine gas at everything, well, it will react. There's fluorine gas inside this piece of glass that's trying to contain it. Probably lasted a few good hours. It probably lasted a few good hours until it was reacted with the fluorine or something, or it just melted away. Interestingly, the more reactive an element is, though, the more stable its compounds are. When we say that fluorine is highly reactive, we mean that a lot of energy is released when it combines with something, other elements as well too. The results are really fascinating as well too. Yes, one of the most famous highly stable compounds of fluorine is Teflon, which was created by accident. Here's the interesting backstory. When Teflon was being created, they were actually trying to create chlorofluorocarbon refrigerants, which are now banned as ozone depleting materials, so I guess it's a good trade for Teflon. Nowadays we use Teflon to make non-stick pans, or for some reason 37 pounds of cylinder of a solid Teflon. Really hard to grab, very non-stick, and you will always slip around. Nothing will stick to it, not even blue tack or glue. That's mainly because it has a tendency to not stick with anything. It just refuses to stick with itself, anything else. It has an atomic weight of 18.9998432. It has a density of 0.001696. And its atomic radius is 42 picometers. Its crystal structure is an oblong cuboid. Its atomic emission spectrum, hey, I got it right. It's only red on the very top, and its electron filing order, it's starting to come up. And it's only found as a gas form in nature, except for that small exception of liquids and solids. Right here. And finally, we have the lighting gas of life, neon. Now, those neon light bulbs that are not orange or red, or orangish red, all those other ones that are called neon light bulbs, if they're not orange or red, does not contain neon at all. Also, another one thing that I should mention, if neon is not inside, if neon light is not coming from inside the tube, but coming from somewhere on the outer coating of the tube, well, then it's not neon. Probably a kind of a really good copy of it. Neon is literally up in lights as well too. It's used to create things. If you put electricity into it, if you conduct electricity into it, it will glow up. And that's that procedure we were able to use inside city streets, such as New York City. Unlike platinum credit cards, which don't contain any platinum at all, or neon lights actually contain neon, but only one type of color, the light orange-red ones. They actually do contain neon, but the other ones, like bluish-green, actual red, those aren't neon at all. There's a variety of spectral lights of neon lights to see inside New York City, except you'll only see one type of neon light. Helium neon lasers were actually the first continuous beam lasers in commercial use until we realized that there was a cheaper version too. There are very few things that you can really do with neon in the same way that you can't rely on other things too. Several thousands of volts illuminate this one piece of neon light too. And we actually are able to contain neon too, just in a little colorless glass. You can only see neon when you light it up with electricity. And that's it. That's elements 6 to 10. So I hope you guys enjoyed this episode. I'll see you guys from 11 to 15. And until then, now, peace. Bye-bye.